Bismillahirrahmanirrahim. Assalamu alaikum. Welcome in the online classes of Smiley Youth Services. And this lecture is for class 6 mathematics, and I am your mathematics teacher. The instructions are: don't raise hand during teaching, ask questions at the end of the teaching, use hand free if you are using mobile and headphone for computer use. Do the home task in your fair copy of the subject. Take care of time for attending the class. If there is any disconnectivity during the class, try to join again within 5 to 10 minutes. Now, this is chapter number 2 from your textbook, GCD and LCM. This is the name of the chapter. And today we are going to discuss from this chapter, the main objectives of this chapter are factors, prime numbers, composite numbers, GCD by forming sets of divisors, means that the factor tree, and GCD by the factorization ladder method. So these two methods that we discussed today, and first we have to discuss about the factors, what are factors, and then we have discussed about the prime and composite numbers as well. And then we are moving on to the methods to finding the GC. First definition we have is the product. What is the product? Product means whatever we just combine together, and then the result of something is called a product. For example, if we have the definition of a product, if you see the product, an answer to be to a multiplication problem means that whenever we are multiplying two numbers together, then we have the product of it. Let's suppose this is the example that 7 multiplied by 8. So 7 multiplied by 8 is equals to 56. So 56 is the product of 7 multiplied by 8. Now moving on to the next one. I think so product is clear to all of you. What is product? Product is an answer to the multiplication problem. Means that whenever we are multiplying any number, so we have the product. Answer is the product. Now the next definition is the fact. A number that is multiplied by another to give a product. Means that we are multiplying two numbers together. Here we multiply 7 and we multiply the second number is 8. So we multiply both of the numbers together and their product is 56. So 7 and 8 are the 7 and 8 is the factor of 56. Means that they both are the factors, means whenever we are multiplying these numbers, so we get the product of 56. Now the next definition is factors. A number that divides evenly into another number called a factor. First we discuss about the factors. What are factors? Means that we are multiplying two numbers together. And if we talk about the factor, just the single number, a number that divides evenly into another number, means that the number by which number we are multiplying the complete number, the another number. So this is called a factor of that number. Means that if we have 56, this 56 is divided by n, as we know that what is the product when we multiplied 8 multiplied by 7, 7 8s are 56. Means that whenever we are multiplying 8 with 7, so it will become 56. So we know that whenever we are dividing 56 by 8, so what we do, we write 8 divided by 56 and the factor will become is 7, because 7 completely divides 56. So 7 is the number which evenly divides 56. So 7 of 56. 7 is the factor and 8 is a factor as well. Means that by 7 and 8 we will divide 56. So 8 and 7 will become the factors of 56. Okay, now test yourself. What are the factors and the product? Means that if we observe number 1, 6 multiplied by 7, so is equals to 42. Means that 7 6 are 42. So 42 is the product and 7 and 6 are the factors of 42. Means that by multiplying 6 and 7 together, so it will make the product, and the product is 42 as well. Okay, now moving on to the next example, that is 63 divided by 9. So is equals to 7. So whenever we are dividing 63 by 9, so how can we divide it? 9 sevens are 63. So 9 multiply by 7, so it will become 63. It means that the product of 9 multiplied by 7 is 63. So it means that 7 and 9 are the factors of 63. Now, moving on to the next third one. by 5 is equals to 40. Means that whenever we are multiplying two numbers together, then we get the product. So in this, we have the product is 40. And what are the factors of 40? 8 multiplied by 5. So 8 and 5 are the factors of 40. Means that we multiply 8 and 5 together. So 8 and 5 are the factors and 40 is a product. So a product and factors is very much clear to all of you. Now moving on to the next slide. Okay, just see the answers. Factors 6 and 7 and the product is 42. Now we have the factors 9 and 7 are the 7 and 9 are the product factors, and 63 is the product of that. Then we have 5 and 8 are the factors and 40 is the product of that. Moving on to the next definition. Yes, the prime numbers. A number that has only two factors, itself and 1, means that those numbers which are having two factors, means that for them by the multiplication we got that product. So what we have in the form of product, we have in the form of product a prime number. Means that a prime number only multiplied by 1 and it's having another one factor. So it's having only two factors, means that it multiply by 1 in itself as well. So it will become the prime number, a number that has only two factors. For example 7 is a prime number because the only number that will divide into it evenly are 1 and 7. Means that they are divisible, or we can say that the multiplication product of 7 is 1 multiplied by 7 and 7 multiplied by 1 itself. So it becomes the product, and the product is 7. So it will become the prime number. 7 is the prime number. Have you observed the wall clock as well? In your homes, you have the prime numbers in your wall clock as well. So that is called the prime time. This is an interesting part, that whenever you see that some program which will come in the prime time, so the prime time, it will means that maybe it comes at 7 o'clock, or maybe it comes at 5 o'clock, or other prime numbers as well we have in the wall clock we have. So these are the two examples, that 5 o'clock or 7 o'clock. Then we have the next examples of prime numbers. If you see 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, and so on. We have a lot of prime numbers. So in a wall clock, we have a prime time, that 2 o'clock, 3 o'clock, 5 o'clock, 7 o'clock, and 11 o'clock. These are the prime times. So these are called the prime numbers. Why they are called the prime numbers? Because they have only two factors. They divide by themselves and with the 1 as well. When we multiplying 1 multiply by 2, so it will become the, so 2 is the prime number. Then we have 3, 4. They are not coming in another table. In a simple words, we are saying that they comes in a single table there itself, and 1, so it will become the prime number. This is the common understanding we all have. Then we have another example, 3 is equals to 1 and 3. So 1 and 3 are the factors and 3 is the prime number. Then we have 17, 1, 7, 17 equals to 1 and 7. It means that the factor of 17 is 1 and another factor of 17 is 17 itself. So we have only two factors of any of the prime number that we have. Okay, now 83 is equals to 1 or 83. It means that 1 is the factor and 83 itself a factor of 83. I think so this is very much clear to all of you. What are the prime numbers? Prime numbers have two factors which are 1 and itself. Next definition we have, which is composite number. A number that has more than two factors, means that it has more than two factors, means that they will divide it by 2, 3, 4, 6, 8, and any of the numbers. So means that they have more than two factors, so they are called the composite number. So the comparison between the composite number and the prime number. The prime number, what is the identification of prime number? The prime number have only two factors, 1 and itself. But if we are talking about the composite number, so a composite number that has more than two factors, so the two factors, more than two factors, means that, for example, the number 8. Number 8. The factors of 8 are 1, means that it comes in table of 1 as well, or whenever we are multiplying 1 multiply by 8, so it will become the product 8. Then we multiply 2 multiply by 4, so it will become 8 as well, the product is 8. Then we have another factor 4 multiply by 2, so 4 2s are 8. Then we have two factors 4 and 2, and then we have the product is 8 as well. Then itself 8, whenever we are multiplying 8 with 1, so it will become the product 8. So 8 is also called a composite number. Why 8 is called a composite number? Because whenever we are having more than two factors, so it will become the composite number. Okay, now we have some more examples of the composite numbers as well. Okay, examples of composite number we have 4, 6, 8, 9, 10, 11. Sorry, not 11. It's 12, 14, 15, 16, 18, 20, and 21, and so on. We have a lot of composite numbers. Okay, now, if we observe that 4, so what are the multiples, or sorry, what are the factors of 4? 4 comes in one whenever we are multiplying 1 with 4, so the product is 4. Then we multiply 2 with 2. So 2 and 2 are the factors and the product is 4 as well. Then we multiply 4 multiply by 1. So we will have the product 4. So 4 having more than 2 factors means that 1, 2 and 4 itself. So it having more than 2 factors. So it means that 4 is a composite number. Like the same we have 6. 6 comes in the table of 1, 6, 2, 3, 2 multiply by 3, 2 3s are 6, 3 2s are 6, 6 1s are 6, 1 6 are 6. So means that we have a lot of factors of 6 as well. So 6 will become a composite number. Like the same, we have the others number 8, 9, 10, and so on. So like the same, we have these are the composite numbers. Okay, one very special, because 1 means that if we are talking about the prime number, so prime numbers start with 2, but we are talking about the composite number, so composite numbers are start with 4. So means that 2, 3, 5, 7, they are the prime numbers, and we are talking about 4, 6, 8, 10, 12. These are the composite numbers. So if we are talking about 1, means that no number is start with 1, not the composite number and not the prime number. So where we stand 1 in which place? So 1 is very special. Why 1 is very special? 1 is not a prime number. Keep it in your mind that this is the very important point for you, that whenever you have 1, so 1 is not a prime number because it does not exactly two different factors. Means that it has no factors. 1 is not a prime number. And if we talk about 1 is not a composite number as well. Why it's not a composite number? Because it doesn't have more than two factors. 1 is not a prime number and nor a composite number as well, because 1 is not exactly two different factors. It has no two factors and not more than two factors. So 1 is stands not a prime number, not a composite number. Okay, now we have the next definition, the next understanding we have, that is prime factorization. What is prime factorization? It means that we are talking about the factors. Factors are the multi factors are the different numbers. Whenever we are multiplying them, so we have the product. So if we are talking about the prime factors, a way to write a composite number as a product and its prime factors as well, means that whenever you are multiplying two prime numbers together, then we have the product of it in the form of the composite number. Keep it in your mind. I'm repeating once again that whenever we are talking about the prime factorization, so the way of finding the prime factorization is The way of writing a composite number as the product means that whenever we are multiplying two prime numbers together, so the product will be the composite number. I'll show you that whenever we are multiplying 2 multiplied by 2 multiplied by 3 means that 2 and 2, 2 multiplied by 2 and multiplied by 3, 2 2s are 4, means that whenever we are multiplying 2 with 2, so it will become 4. 2 and 2 are the prime number. 2 and 2, these are the factors, and these two factors also called the prime numbers. 2 and 2 are the prime numbers, and they are the factors, and whenever we are multiplying 2 with 2, so 2 2s are 4, and 4 is the composite number. Why 4 is the composite number? Because it's having more than two factors, and 2 is the prime number. So we are multiplying prime numbers, and we have, then we multiply 2 multiplied by 2 equals to 4, and whenever we are multiplying 4 multiplied by 3 means that 4 multiplied by 3, whenever we are multiplying the prime numbers together, 2 multiplied by 2 multiplied by 3, they are 2, this 2 and this 3, they all are the prime numbers. Whenever we are multiplying these prime number, so we get a composite number. 12 is a composite number, so these are the prime factors. Okay, now, or we can say that we can write another way like this: 2 exponent 2 means that if we write 2 multiplied by 2, or in place of 2 multiplied by 2 we write 2 exponent 2 multiplied by 3, it means that equals to 12. So 2 3s are 12, not 2 3s are 12, it will become 2 exponent 2 means that we have 4, right? And whenever we are multiplying 4 multiplied by 3, it means that 4 3s are 12, so it will become the composite number. Now, how do a prime factorization? We have two methods of prime factorization. First method is a factor tree method. Whenever we are finding out the prime factorization, what is a prime factorization? I told you in the starting that whenever we having a product in the composite for number, by multiplying two prime numbers together or three prime numbers together, whenever we are multiplying any of the prime number together, two or three prime numbers together, and then we have the product in the form of a composite number, so it means that it's a prime factorization. Factor tree: write down any composite number. First step to forming the factor tree method, so write down any composite number. First we have to write any of the composite number like 48, and start dividing the prime number. Start with 2 means that whenever we are finding out the prime factorization, so we will start with 2 means with the smaller number. So what is the smaller number? The smaller number is 2 in the prime numbers. So the smallest number is 2 in the prime number. So first we take 2. If the composite number is divisible by 2, write it down and find the next factor. If not, check if the factor is evenly divisible by 3, 5, 7, 9, etc. Like if we have 48, then we will divide 2 multiplied by 24. Means that the first factor is whenever we are multiplying 2 2s are 4 and 2 4s are 8. So we have 24, right? Then we have 24, and after that, what will we do? Check the factor. If they are prime, you are done. If they are not, proceed to fourth step. So if one of the factor is divisible by 2, write it down and find the next factor. If not, check it. The factor is evenly divisible by 3, 5, and 7. Like 2 multiplied by 2 multiplied by 12. The common thing is that we have 48, 2 divided by 1 are, and then we have 2 6 are 12. So what is the product? We have 6. 6 is also a composite number, so we can divide this composite number again with 2 as well. Then we multiply 2 multiply by 2 multiply by 2 multiply by 2. So not focus on this one, just firstly you have to focus on this one. 2 multiplied by 3, 2 multiplied by 3 equals to 6. So it means that firstly we divide 2 with 48. So we write 2 over there. Then we divide 2 with 24. So we write again 2 over there. Then we divide 2 with 12. So we write over there. We multiply 2 with 6. So we write over there. Then we have the last composite number is 3. So write the prime factor in the exponent form. So how can we write a prime number in the exponent form? Prime factorization. So we have these twos. We have 1, 2, 3, 4. So these 4 twos we have. So what we do, we can just make them the exponent form. So we have to write in the prime factorization method. So how can we write them in the prime factorization method? The method is that whenever we are putting the exponent, so first we have to count the factors that we have. We have 2, 1, 2, 3, 4, and these all are the same. So we have 2 exponent 4. 2 exponent 4 means that 2 multiply how many times? 2 multiply 4 times, and then we have the product, which is 48. But how can we find the product of 48? Means that we have to write 2 exponent 4, and then it will multiply with the other number, which is 3. Okay, let me show you once again that how can we find out the prime factorization via factor tree method. So I will show you that first what we can do. I'm repeating once again that how can we find out the factor of 48. So first we take 48. 40 is the 8 is the composite number. Then what we do, we can divide it with the prime number, and the prime number is 2 we have. So we multiply 48 with 2, so it will become 24. It is completely divisible by 2. So 2 is the factor of 48, and the product is 24 we have. Then we multiply, then we divide 24 again with 2. So 2 divided by 24 completely, and then the product we have, which is 12. Then what we do, we divide 12 with again 2. So it will completely divisible by 2, and it becomes 6. 6 is the product we have. And how many factors we have right now? We have 1, 2, 3 factors of 48 right now that we will find out in the factor tree. Then we have 2 multiplied by 2 multiplied by 2. Again, we will divide 6 by 2. So it will become 2 3s are 6. Then 6 is completely divisible by 2. So we have to write the prime factors in the exponent form. So how can we write the exponent form? That 2 exponent 4 multiplied by 3. So 2 exponent 4 means that we have the multiplication of the value of 2 4 times, and then we will multiply it with 3. So it becomes 2 2s are 4, 4 2s are 8, 8 2s are 16, and 16 3s are 48. Now find the prime factors of 4. How can we find out the prime factors of 4? Give me your answers in the chat box that we are finding out the product of we are finding out the prime factors of 4. So how can we find out the prime factor of 4? 4 is the prime number or a composite number? Yes, we have 4 is a composite number. So first we have to divide it with the help of the prime number, and the smallest prime number we have, which is 2. So we have to divide 4 with 2. So 2 multiplied by 2. 2 2s are 4. So 2 is completely divisible by 4. Then we have prime factorization. So prime factorization in an exponent form. How can we write it? We write it 2 exponent 2. It means that 2 multiplied by 2 equals to 4. 2 multiplied by 2 means 4. It will become completely divisible with 4. Now find out the prime factors of 6. So 6 is a composite number. Why 6 is a composite number? Because it's having more than 2 factors. How many factors it's have? Means that it multiplies with 1. So it will having a 1 factor 1. Then we have 2 3s are 6. So 2 is the factor and 3 is also a factor of 6. Now we can completely divide the 6 with the prime number, and the prime number is 2, and we multiply it with 3. 2 3s are 6. So it will completely divide. And how can we write in the exponent form? Now, there is no exponent form of 2 multiplied by 3 because we don't have the same factors of 6. So we will not write it in the exponent form. Keep it in your mind whenever we have a same number. So we will write it into the exponent form. If we don't have the same number, so we will not write it in the exponent form. Okay, now we have 27. So how can we find out 27 factors? Prime factors, 3 multiplied by 9. 3 nines are 27. So 3 and 9 both are the different factors of 27. So we will not write them in a factor form. But we have 9. So 3 multiplied by 3 and multiplied by 3. 3 threes are 9, 9 threes are 27. So we have 3 factors like we having the same factor. So we will write it in the exponent form. 3 exponent 3, it will become 27. Now moving on to the 12. 12, it becomes 2 multiplied by 6, and then we have 6. So 2 multiplied by 3. So if we have two similar factors, we have 2 multiplied by 2. So we will write them in an exponent form. 2 exponent 2 multiplied by 3. So it will become 12. Now we have the same example of 18 as well. 2 multiplied by 9, and then it will become 2 multiplied by 2, 3 multiplied by 3. So we have two factors over there which are same. So we will write them in the exponent form. 2 multiplied by 3 exponent 2. In this form we also write them. So it equals to 18. Now you have an option that the following screen illustrate another method that you can use to find the prime factorization of a composite number. So we will find out the next prime factorization of the composite number, which is a ladder method. The previous method is a factor tree, and then we have the prime factorization with the help of the ladder method. Okay, this is very important for you because this method is also present in your book as well. So write down a composite number, a very simple way, because we are finding out the prime factorization. Prime fact we are finding out the prime factorization of a prime number, composite number. So what we can do, first we have to write 18, and then how can we write? Start dividing by a prime, start with 2. Means that we have a smaller number, the prime number is 2, so we start with 2. If it is not divisible by 2, so we will form or write another number which is 3, 5 maybe, or the other number as well. Right on the left of the L, ladder method. Whenever we are saying that we are forming a ladder method, so we are forming L shape. Means that we are forming a L shape like this, and then we have to write the factors of it. Means that first we have to write 2. So 2 is divisible by 6. 2 6 are, sorry, 2 9s are 18. I'll make the mistake. 2 9s are 18. So what we will do, we then multiply 9. So 9 is not completely divisible by 2, but it will divisible by 3. So what we can do, we can write 3. Check the factor. If they are prime, proceed to step 6. If not, continue the process. Okay, now 2 and 9. 2 and 9 is completely divisible, divide 18. Then we have 3. 3 divided by, we can again make the L ladder, and then we can write 3 divided by 3 multiplied by 3, which is completely divisible, 9. Means that 3 multiplied by 3, so 3 and 3 are the factors, and then it will divide, completely form the product, which is 9, right? So 9 is completely divisible by 3. Then we have the next one. We are not taking 2 because we have the another last composite number. Sorry, yes, we have the next number, which is 3. So 3 is not a composite number. 3, we have the prime number. So what we can do, write the prime factor in the exponent form. Why we are writing them in exponent form? I told you that whenever we have the prime factors in a similar similar way, and we have the product, the last product in the form of prime number, so we have to write them in a exponent form. So we have to write 2 multiplied by 3 exponent 2, 2 multiplied by 3 multiplied by 3, and we have to write them in exponent form, that 2 multiplied by 3 exponent 2. Okay, now find the prime factorization by a ladder method. We can take another number, that is 56. Then we make a ladder like this. And then we take 2. First, we have to start with the smaller number, which is 2. So 2, 2s are 4. Then we have the remaining one, which is remaining from 5, means that we can minus 4 into 5. So 1 is remaining with 16. So it will become 2 8s are 16. Keep it in your mind whenever we are writing 2, 5 over there, and we will divide it with 2. So 2 2s are 4. So we will minus 5 from 4. So it will become 1 is remaining. So 1 is with 6. So it will become 16. And then what will we do? We can write 2 2s are 4. 2 8s are 16. Then we will next form the ladder again. And then what will we do? 2. Again we will take 2. Then 2 1s are 2. 2 4s are 8. Then again we will form the ladder. We have another composite number 14. Then what we do, we can take 7. 2 7s are 14. Then what we have again in the last product we have 7, the prime number. Then what will we do? We can form the prime factors. What are the prime factors? We are having the prime factors are 2, 2, 2, and the last number is 7. This is the ladder, and this ladder shows that these are the prime factors of 56. So how can we write the prime factors of 56? 2 multiply by 2 multiply by 2 multiply by 7. And whenever we are multiplying these numbers together, we will get the product, which is 56. So now how can we write them in exponent form? Have you seen that they are the exponent? Why we are writing them in exponent form? When we have the last number is 7, 7 is the prime number, so we will write them in an exponent form. How can we write them in an exponent form? We have 1, 2, 3, 2, 3. We have 3, 2 over there. So what we can do? We can write them 2 exponent 3 multiplied by 7. 2 exponent 3. 2 exponent 3 means 2 multiply itself how many times? 3 times. And then it will multiply by 7. If we consider this exponent form, so it will become 2 multiplied by 2, 2 2s are 4, 4 2s are 8, and 8 multiplied by 7, it will become 56. The product is same over there. So this is the ladder method to finding out the prime factorization of a composite number. Now, 1 is not a prime number, not a composite number. 2 is only a even and prime number as well. 2 is a even and prime number as well. Not all odd numbers are prime numbers. Means that if we have 9, so 9 is not a prime number. Why 9 is not a prime number? Because it's not having only 2 factors. It having more than 2 factors, so it will become a composite number. Okay, 15, 21, 27, 33, and 35, they all are not, they all are the odd numbers, but they don't have the prime numbers itself. Okay, all composite number can be written as the product of a prime number. Whenever we are multiplying a prime number together, so it will become the product of a composite number. Whenever we are multiplying prime numbers together, I'll tell you again, then it will become the product in the form of composite number we have. Now that's all from my side. I think so it will very much clear to all of you. And what we discussed in the slides, we have discussed about the factors, the products, and the prime numbers, composite numbers. From my side, thank you so much. Allah Hafiz.